Hi everyone, I'm sorry I'm not there with you today, but we will be continuing or starting in Chapter 4 and doing the first day of notes just by way of video. So if you could grab your notes packet, open up to that first page of notes, and we can get started. So if you look at the heading, it says we will write linear equations in slope-intercept form. So in order to do that, let's think about what we need to find. We're going to need to find the slope. We will need to find the y-intercept. And then we have the parts we need in order to write an equation in our slope-intercept form, which is known as y equals mx plus b. All right, so let's get to it. If we look at example 1, we're given some pieces of information. We're asked to write an equation in that slope-intercept form, and then go ahead and graph it as well on the grid below. So let's look at one or two of these together. So the first one, we're told we have a slope of -2. We have a y-intercept of +5. So we know m is -2. We know b equals +5. So we can go ahead and plug that right into our equation, y equals mx plus b, and have a linear equation of y equals 2x plus 5. So let's go ahead and take a moment and graph. Think about where you'd start. We would go ahead and start by having a point at +5 on the y-axis. And from that point, +5, we would count down 2 and to the right 1 and build a few more points on our line. Or we can go up 2 and then to the left 1. So we have a nice negative slope, a nice downhill slope where we can connect our points and see that line. All right, let's take a look at letter B next to it. Kind of the same idea. We're given a slope. We know that m equals +1/2, but instead of being told the y-intercept, we're told that it goes through the point 0, -7. But if you take a look at that point, knowing that the x-coordinate of 0 makes the y-intercept -7. So our value of b is -7. So think about the equation. Let's plug it in. Y equals m is 1/2 x, b is -7, so -7, and we have our equation in slope-intercept form. And we can graph just like we did the other. Start at that y-intercept down at -7, and go ahead and count out your slope. This slope is positive, so it'll be an uphill. Up 1, to the right 2, count out a bunch of them. Or we can go down 1, and then to the left 2. Give yourself enough points that you can easily connect, stay on path, and have your line. All right, perfect. Go ahead and press pause now. There are 2 more problems, letters C and D, down below on your paper. So go ahead, press pause, give those problems a try, and once you're done, come back and hit play and check your work. All right, welcome back. Here's problems C and D already completed, so hopefully you tried them as well. Go ahead and check out your slopes and y-intercepts for each one of those problems. Check out the equation that was written along with the graph. Watch your slopes, negative slopes going downhill and positive slopes going uphill. And then once you are sure that everything is okay, you can either press pause and take a minute to look over the problems and verify if you have any errors, what happened, or go ahead if you're all set and everything is correct and flip over to the next page. All right, here we are on the back page. So back page is asking us to write a linear equation for the lines below. Now, it didn't say what form of a linear equation we need to write, but we said in these notes we're going to be working with slope-intercept form. So we have that y equals mx plus b. So that's our job. Let's find the slope from the line, and let's find the y-intercept. So think about the slope. To find the slope, we're going to need 2 points. And to find the y-intercept, we're going to scan down that y-axis and find where our graph is crossing the y-axis and identify that coordinate. All right, so we have the y-intercept at -5. Okay, there's our y-intercept, 0, -5. And our slope, we need to find another point. So if we kind of look around the line, scanning up and say, oh, well, here's a great point. Okay, this point is up here at 5, 5. So we can either use our coordinates and calculate the slope with the slope formula, but even easier than that, we can just count from one coordinate to the other. So from 0, -5, I'm going to move up, which would be a positive move, and to the right, another positive move. So count how many spaces. From down at -5 to +5, we are going up 10 units, and from 0 to 5, we are going to the right 5 units. So my slope, rise over run, we went a rise of 10 and a run of 5, gives me a positive uphill slope of positive 2. We already identified the y-intercept down here at the bottom to be at negative 5, so we have everything we need to write our equation in slope-intercept form. Y equals, slope is 2, then we have our x, minus the y-intercept, 5. All right, go ahead, hit pause again, look at the problem in letter B and see what you can do with it. And then once you're done, go ahead and hit play and check and see, did you come up with the same equation as I did? All right, welcome back. Take a moment, check letter B there. See, does your equation say y equals negative 2/3 x plus 4? If it does, you're ready to move on to example 3. If not, press pause and take a moment to look over the problem. All right, on to example 3. In example 3, we're asked to write an equation again, and it passes through the following points. So we're given two different ordered pairs. Now looking at the ordered pairs, I have 3, negative 1, and 0, negative 5. So 0, negative 5. If the x is 0, then the y-coordinate would be the y-intercept. So I know the value of b. b is negative 5. So we need the slope, and we need the y-intercept. So I have that y-intercept. So what's the slope? Well, 2 points will allow me to calculate the slope. Remember our slope formula. Our slope formula says m equals y1 minus y2 over x1 minus x2. So we could take our two ordered pairs, plug them in for the appropriate values of x's and y's, and calculate our slope. So let's go ahead and do that. Y equals, pick a point to start with and just be consistent. Negative 1 minus negative 5 divided by 3 minus 0. Go ahead and simplify. Negative 1 minus negative 5 is 4. 3 minus 0 is 3. So I have a slope of 4/3. Well, knowing a slope and knowing a y-intercept is everything I need to go ahead and write that equation in slope-intercept form. Y equals 4/3 x, 4/3 x minus 5. All right, go ahead, take a moment, hit pause, and try letter B. All right, thanks for trying that problem. Excuse me. Go ahead, check your equation. Do you have y equals negative 1/5 x plus 6? If so, we're ready to move on. If not, again, press pause, take a look at your work, check out your slope calculations, see if everything, you had any errors anywhere, and try to find them. And then once you're ready, go ahead and move on to example 4. All right, let's take a look at example 4. We're almost done. Example 4 is asking us to write an equation again, and that equation, though, we are now given function notation. So to write our linear equation, I have to pull the information that I'm provided with from this function notation. So let's think back. We talked the other day about f of x and what f of x represents, and how to know, do I plug in a number for x or does it represent the output, the y? So let's think about function notation. F of x, we said, is a fancy way to represent y. So if I write that up above the information that I'm given, then I can easily see that my x-coordinate is 3 and my output, the y-coordinate, is 2. And likewise, it would work the same in the second f of x notation. My x-coordinate is 0, my y-coordinate is 6. And when I recognize x is 0, then I know the 6 is also serving as my y-intercept. So 2 points are just like the problems we had up above, where 2 points will help me identify the slope. So we need a slope, we need a y-intercept, but we actually know the y-intercept. It was one of our coordinates, a 6. So we can calculate our slope and then write our equation. So think of that slope formula we had up above. Y minus y divided by x minus x. Simplify the numerator and denominator, and we end up with 4 over negative 3, or a slope of negative 4/3. We have a slope, we have a y-intercept, we can write an equation. Y equals negative 4/3 x plus 6. So it's basically a different way of presenting the same 2 points in function notation form rather than in just ordered pair form. But you are more than welcome to transfer them into ordered pairs and then treat them just like you did the problems up above. So take a moment, press pause, and your turn to do letter B. All right, thanks for trying the problem. Let's check and see your equation. Do you have the equation y equals -3/2 x plus 6? If you do, we're ready to do the last problem. Keep moving on. If not, press pause and go back and check out those calculations you made, either writing the coordinates or maybe calculating the slope, and see if there's an error somewhere. All right, on to the last problem, or think about it problem. And it says we could sketch a graph if we think it might help, but let's go ahead and see what we have to work with. Our job, write an equation, just like we've been doing, of a line that has a slope of 0, that sounds familiar, and goes through the point 0, -3, which happens to be the y-intercept. Oh, where did it go? Somewhere we lost our paper. There it is. Okay, so let's go ahead and write our equation. So we know y equals 0x, slope, times x, and then our y-intercept, and our y-intercept was -3, so -3. But 0 times x is 0, and 0 minus 3 would make our equation simplify to just be y equals -3. What type of line is that? Y equals a number. Y equals lines are horizontal lines where every y coordinate on the line will have a value of -3 for every point on that line. So we know those slopes that are 0 represent those horizontal lines. Slopes that are undefined represent our vertical lines. All right, well, great job, everybody. Thank you very much for going through the notes with me, and I will see you tomorrow.